many of you are just forced to write JavaScript, but you're really, you'd rather not? That's really most of us, right? Like, when you have a choice, how many people just choose JavaScript even when you have other options? Unfortunately, we don't have a lot of other options, especially if you want to do like highly interactive sites in the web. So that's what this talk is about. This talk is about your web applications, the stuff that you're building, and how it's eventually going to break in the hands of your customers. This talk is called JavaScript's Most Wanted, and it's about outlaws. It's about the JavaScript errors that happen in production for your real customers, even when you never emerge during testing. Even when all of your developers and all of your QA staff, if you have them, never expose stuff, but crazy stuff happens when you actually put something into production on the real internet. The internet, in a lot of ways, is still the wild, wild web. It is, as Crockford says, the most hostile development environment imaginable. Because JavaScript itself is kind of hard. There's a lot of complexity just in JavaScript as a language. And then we add on top of that we're going to take this JavaScript application that we've built, and we're going to ship it down over an internet that is, as you well know, not always very reliable. Honestly, in the last few days, I've come to new realization on how unreliable it can be accessing it from this part of the world. I'm sorry. So you take this JavaScript app and you try and shove it down these pipes across this internet into a browser environment that you also don't control. You're trying to just build an application that will run in your customer's browser that maybe you built it in Chrome, but they're running it in IE9. Does it work? Should it work? Maybe not only are they running it in some old version of a browser, but they've put a bunch of gunk into it. They have Ask Toolbar, malware is injecting ads into your page, or they have an ad blocker that's stripping out a bunch of analytics services. And does your app still work when all of the analytics services are gone? There's so much that's going to break when we actually get into the real world. And so that's what we're going to do today. So we're going to talk about 6 of the most common errors that I see happening in production apps. How do they manifest themselves? How do we see them in reporting tools? How do we diagnose them? We're going to open them up live in Chrome Debugger, and we are going to diagnose, fix them, and show you how you can prevent these things from happening in the future. Sound good? Awesome. So in order to expose these bugs, we need a honeypot. We need something for these outlaws to attack. And so I've built this app for all these outlaws to come at. Now I want to show it to you. It's called Soliloquy. So Soliloquy is this thing I've been working on. And it's what I call an anti-social network. It's kind of like Twitter. So just like Twitter, you can type in, narcissistic thoughts about yourself and what you're doing. And just like Twitter, those will show up here in a timeline that you can look over. And just like Twitter, I have annoying inline ads that are injected into those timeline. And I have some amazing sponsors already from Cats and Bacon, and more Bacon, and Mr. Dundee. And so I have all of these things coming in that's just like Twitter. But unlike Twitter, I've left out one of the most annoying things. Other people. Because with Soliloquy, it's all about you. Only you can write status updates, and only you can see your status updates, right? So this Soliloquy it's going to be huge, right? If anybody here is, venture capitalists, get your term sheets ready. This thing is going to be amazing. But I want to make sure that Soliloquy has a really great user experience. I want people who are using this to have a good time when they're doing it, and make sure it doesn't have any errors. None of the outlaws attack. And so in order to do that, I'm going to protect Soliloquy with another thing that I work on, which is Track.js. So Track.js is a JavaScript error monitoring tool that helps us understand when things are going to go wrong. And we're going to show just a little bit about that, but this isn't really about that. What TrackJS does, this is the entirety of the sales pitch, is we capture really detailed error reports about like how did a user get into this situation, what were they entering, what were they clicking on, what kind of things were happening in the console that led to an error, so that we can give people really detailed error reports. And I wrote it, so like if you want to know more about it, we can talk later. So let's get into actually a real error. So here's our first wanted poster. This is our most wanted. And this is an outlaw called Scripty Joe. How many people have run into Scripty Joe? Script error. This is the most common error that has ever been reported into TrackJS or any time I've worked with a production app. So what happens with Scripty Joe? We just launched Soliloquy not that long ago. And we only get about 2,400 hits a week. And script error happened right away. As soon as we launched, 2,400 times this script error happened. And it didn't just affect like one-off browsers. It didn't affect just, IE10 or whatever. This is affecting everything. This is affecting recent versions of tons of different browsers across the board. So let's take a look at Soliloquy itself, and we'll look at some code, and we'll see if we can diagnose what's going wrong. Whoa. All right, so here it is. Let's pop open the dev tools and see what we can see. Maybe we should look at the code first. So here is the code of Soliloquy. I trust you all have signed your non-disclosure agreements under your chairs, right? Good. All right, we'll move on. So here's the code backing Soliloquy, and it's not all that complex. But one of the things we need to do is we need to capture these errors that are happening in our app and show and send them back to my server so that we can like see what's going wrong. And one of the ways you could do that was with TrackJS, but for the purpose of this demo, we're going to do this right here. So window.onError, if you're not familiar with it, is this function that's existed since the very beginning of JavaScript in the browser. And it allows you to basically attach a function to get any unhandled error that happens on the page. And it'll just dump into this function, and you can do stuff with it. And so what I'm doing is I'm just going to push it in the console so that we can see it. And so what this is going to show us is what is available to us programmatically when an error happens. What can we see about it?
Won't it go to the console anyway?
It will go to the console, but in a slightly different way. And that's what I'm going to show you right now. So if we pop this open and reload the page, we see some errors on Soliloquy. Now, the second error, is this big enough? Is this too small for anybody? All right, good. So this second error is this uncaught reference error. Now, this is like a real error. This is informational. But this isn't JavaScript telling us this. That's Chrome telling us that. Chrome operating at a different level of abstraction. It's actually telling us real data. What's available to us programmatically that we could actually like send back to our servers or dump into a log or try and do something with it is this right here, is this array. Programmatically, we think there's a script error. We don't know the file, we don't know the line, we don't know the column, and we don't know anything about it. It's just, your stuff's broken, dude. That's all we know. Of course, like it's a real error, but it's being hidden from us. So why is it hiding it from us? So what's interesting about this is that the underlying error is coming from this file called the sidebar ad provider. And what's interesting about the sidebar ad provider in this case is not necessarily even what's in it, but where is it coming from? The main app where Soliloquy is coming from right now is a domain called www.soliloquy.local. But this file, this sidebar ad provider, is being served from somewhere else. It's coming from this place called ads.local, which is a different origin. So how many people have heard the term same origin policy? That's what we're dealing with right here. Part of the same origin policy is trying to protect information from leaking between origins. One of the ways information can leak is in an error. And so because sidebar ad provider is in a different origin than the rest of the page, Chrome is trying to protect it and say, hey, I'm not actually going to reveal any details about this thing. I'm going to strip everything out of this error and say, something broke, you got to go figure it out yourself. And so that is the actual origin, or the browser origin is the origin of script error. But there's a way we can get around it. So sidebar ad provider is coming from this other origin, but we can tell the browser to go ahead and trust origins and let that information cross. And we do that with cross-origin resource sharing, or CORS. You may be familiar with CORS if you use do AJAX calls to different domains, if you're integrating with third-party APIs. That's typically where CORS comes in. But it's also really useful in this case, because when you take a JavaScript file and you serve it with the CORS headers, like I'm doing here, access control allow headers and access control allow origin. These are the HTTP headers that come from CORS, or cross-origin resource sharing. And what this is doing is, because the web server is serving this file with these headers, it's saying, hey, you can go ahead and use this anywhere. I don't mind. It's cool. We don't need to hide this information. And so we're already doing that. So we've done half of the problem. But now we need to tell the browser that our page also trusts that file. Both sides need to trust to make sure that works. So there's a really cool way you can do that. And it's fairly new inside the HTML spec. So here's all of the script files coming in to Soliloquy. And you can see that they're all coming from different places, right? Nothing is actually coming from www.soliloquy. I have a bunch of my files coming in from a CDN, which a lot of people do for performance reasons. And then I have a couple of different files coming in from ads.local. And so I would have script error all over my app. Anytime anything goes wrong, it's guaranteed to be on a different origin right now, because that's where all of my scripts are coming from. And so script error would be all over this app. But we can get around that by, they're already being served with CORS headers, and now we just need to tell the browser to trust these. And so we do that by decorating these script tags with cross-origin anonymous, which is new inside the spec. And what this tells the browser to do is, when we're loading this file, look for those CORS headers. And if those CORS headers are there, same origin policy doesn't apply anymore. We're good to go. We trust this file. Both sides trust it, and we're good to go. So I'm just going to copy and paste this guy down. And if we reload our page here, we can see that we actually haven't fixed the error itself, right? We haven't changed anything. However, what we're able to get now is real data. So programmatically, we now know that a bunch of our users are having this uncaught reference error. This coming from sidebar ad provider on line 20, column 16, with a stack trace. And so by putting this little change, we're able to get around script error and actually start addressing some real problems in our app. And so this was Scripty Joe. Scripty Joe comes from browser obfuscation due to the same origin policy. And it's really noisy. If you start capturing JavaScript errors from production on your apps, this is going to be one of the first things you run against. And it's going to hide all kinds of good details from you. And so you're probably going to have to deal with this sooner rather than later. So there's really two ways you can do it. If you have to load from third parties, which if you're using a bunch of services, inevitably you'll have to reference something from somewhere. The way to do it is with CORS and cross-origin attributes. Alternatively, just load everything from the same origin, and then you don't have to deal with this problem. That's, of course, a performance trade-off. You have to deal with whether or not the advantages of loading from CDNs or other parties is worth losing that visibility. So this was our first outlaw. It was hiding the other outlaw, which is Jane Adsy. Jane Adsy is manifesting itself as this error, which we saw a few minutes ago. This get random ads is not defined. And what's interesting about get random ads is not defined is that I've been monitoring Soliloquy for a little while, and I was a little nervous every time I'm leading up to a talk, and so I don't want to change anything. We went into code freeze on Soliloquy. I didn't want to break it last minute, and so I hadn't checked anything in for a couple of weeks. But all of a sudden yesterday, for no apparent reason, bam, my error rate is up 6,000%. Like, what is going on? I didn't change anything. You didn't change anything. Why is this thing blowing up? So let's take a look at Soliloquy and see if we can figure out, like, how is this breaking and why is this breaking? So now if we take a look at our console, here's that same error that was being hidden by Scripty Joe before. And let's actually, like, dig into this a little bit. So here Chrome is just telling us, hey, this is an uncaught reference error, get random add is not defined. So it's coming here from sidebar ad provider. And the Chrome dev tools are like really smart. And it's basically telling us exactly where this thing is going wrong. It's saying, hey, we tried to call this function inside of this file, and we didn't, it's not there. There is no function called getRandomAdd. So let's maybe take a look at this file. This isn't mine, right? This isn't part of my app. This is something from an advertising provider. I put this thing on my site to try and get ad revenue so I could like monetize my site. But I didn't write this code. So maybe we'll take a copy of it down locally and we'll see if we can fix it. So this was the sidebar ad provider. And it was this line here, this line 20, get random ad. So if we just look around like it's not defined, let's see if we can find where this is. Looks like we call it a couple of different places. Down here at the bottom, there's this function called getRandomAds. Maybe this was just somebody like who didn't know how to exit Vim correctly and left a little thing. Let's just try it. Let's just try it. So we make that change and now let's reload. Oh look, no, there's no error. And look at all these new ads I have now. I got even more bacon and bears and Mr. Dundee. I actually just put Dundee into this demo for you. Usually I use David Hasselhoff, but I felt like this might be better. All right, so this error was trivial, right? It was a typo. We all make typos. I've made lots of typos. The problem here is that this was a typo that was introduced beyond any controls that you or your organizations can have, right? You're relying on a third party who is writing JavaScript that you are injecting into your app at runtime, like whenever a user connects to it. This is unplanned changes. Anytime you are bringing in a script from somebody else, even if that somebody else is somebody really trustworthy, like Google, or Microsoft, or Twitter, or Stripe, or Braintree, or a payment provider. Anytime you're doing it from anybody, you are giving control of the runtime experience of your app to another organization. And we need to recognize that. Like, we kind of gloss over that fact today. But we are introducing the ability for some other team to break our app even when we're not in active development. A web app should never not be in maintenance. You can never just disband the team and say, hey, this app is done, because the web isn't done. The web is still dynamic and it's still injecting stuff. And so anytime you're building an app and you're bringing in third party, you have to weigh the risk, weigh the value of bringing in third parties versus the risk that they're going to create problems in your app downstream, compatibility with new browsers, etc. Okay. So those were our major blocking errors. So now let's get into some stuff that's a little bit more subtle. So this is Clara context. And Clara context reports an error as cannot read a property of undefined. And so we're seeing this a lot inside of Soliloquy. And one of the things that we're looking at here is that this error is manifesting as cannot read property destroy of undefined. But every time it happens, what we're seeing in our logs is that immediately before it happens, the user's clicking on this button, this JS-delete- statement, and then this error happens. So I think I have enough context that we could like go into Soliloquy and see if we can recreate that. So let's just refresh this. So I happen to know, because I wrote it, that JS-stat statement, the delete button, is this little garbage can right here. So if we just give this a little refresh, And if we try and delete one of these statements, we see that we printed into the console that we were going to attempt to delete a statement with an ID, but it blew up. Uncaught type error, cannot read property, destroy of undefined. Exactly what we were seeing in our logs. So let's see if we can figure out why that's happening. So I'm going to just use the Chrome tools here, and we'll pop open and take a look at the stack trace. That's a kind of a terrible stack trace. Some function that doesn't have a name blew up on statement view.js, line 30. That's not really a very cool stack trace. I don't really understand anything from that. But recently, well, not recently, maybe 12, 18 months ago, Chrome shipped with a new a feature that's off by default, but it's really cool. So if you go and look in the sources tab, where you look at all this code, there's this little checkbox down here called async. Now this is amazing. So JavaScript is an async language. So much of the stuff that we do with JavaScript is we're setting up functions to be called back later. Do something later when the user clicks on this. Do something later when the network is done. Do something later after a timeout has occurred. But whenever we set up these things, we lose context because all of the code that we were setting up our application and deciding what callbacks to attach stops, and then we wait for users to interact or networks to complete, and then starts back up. And we lose all of the context, all of the logic about what functions we're executing, we lose in those asynchronous boundaries. We don't know why, or we know what blew up inside of a callback, but we don't know what attached that callback and why. And that's what this async checkbox does. So I'm going to click it, and it's going to be amazing. So we're going to refresh this, and we're going to do the exact same thing here again. I'm going to try and delete this statement. This time we have async stack traces turned on. I'm going to delete it. Still don't have this problem fixed. Let's pop open and take a look at this stack trace now, though. Bam! That's awesome. All right, so we still have this same line. This is what blew up, an anonymous function on statement view.js line 30. What we know is that that anonymous function was passed in a callback to set timeout. And that set timeout was called inside of a function that actually has a name called onDelete, which is also on statement view.js. We know that onDelete was called by a dispatch thing from jQuery and an event handle, which is kind of enough to know that, like, hey, there was some event that happened. jQuery was wrapping up an event, and I'd said, hey, handle this event with onDelete. OnDelete said, hey, I got to do stuff later. I'm going to pass this thing into set timeout, and that's what blew up. And now I haven't even looked at code yet, and I have way better context of what happened because I can see this history. So let's take a look at statement view.js line 30 and see if we can actually get to the bottom of it. So this soliloquy happens to be written in Backbone, which I know is like an ancient framework in JavaScript terms, but like it doesn't really matter at this point. We're just talking about raw JavaScript. So let's take a look at this onDelete function. Here's line 30. Give you a moment to digest that. Has anybody spotted the problem? Yeah. This is the most common error in JavaScript, even for very experienced people like myself. I make this error all the time still. We're passing a function into a callback, or we're passing a function into an asynchronous thing, into set timeout. And inside of that function, we're using the keyword this, implying that there is an object context that we're running inside. And I want to access properties or functions on that context. This is some object that represents statement view on line 29 and on line 31. But on line 30, this is cast into the future when this set timeout expires. And in the future, we don't know what this is. In this case, This is probably going to be the global object. It's probably going to be window. When set timeout expires and it calls our callback, it doesn't know the context it was executed in. And so it blows up. And so the specific error that we're getting, is cannot read property destroy of undefined. It's trying to find a property destroy on this thing called this.model. But this isn't what we think it is. And so this.model ends up being undefined. And there isn't a property called destroy on undefined. And that's why that error gets generated. So there's a couple of different easy ways to fix this, right? And probably the most common is just to save off the context that you want to operate in. And so depending on which JavaScript book or blog you might have read first will dictate your preference on whether or not you feel this should be called var self equals this or var that equals this, right? Who likes self? Who likes that? I like that. Anyway, so we basically grab a reference to what is the context that we care about, and we store it into a value that we control. And then we can fix it just by saying that.model.destroy, right? See, I like that because it's go destroy that model. You've taken this and you've made it a that. It's not yourself anymore. It's somebody else. Anyway. All right, so this would be one easy way to solve this. We could check this real quick and make sure that this works. Yay, we can delete a statement. But there's a bunch of other cool ways we could do this too. So for example, this is a really simple function. It only references model.destroy. So we could be maybe a little bit more explicit. We could say something like var model equals this.model, and then we'll just reference it as model.destroy. That would work too. Or we could use some new advanced JavaScript-y things, and we could actually set the context that we want to operate in. And so then let's just back all this out and leave it as this. What if I just want to make sure that the context of this function, the whatever this is something I control? And we can do that because in newer releases of JavaScript, functions have some things we can do with them. We can bind them. What bind lets us do is it lets us set whenever this function is called, here's what your this is. I don't care what object you're executing in. I don't care where you put the function. We are attaching a context to a function permanently. And so we can do that by just saying, hey, bind the value of this from our outer closure into the value of this on the inner closure. And this should work if we refresh this. Yeah, we've bound it. But this isn't the most compatible thing in the world, right? This works in Chrome, it'll work in Edge, it'll work in Firefox, but it probably won't work in IE9. So if we want it to work in older browsers, which I do for Soliloquy, we could polyfill this. So I'm using Backbone here, which already takes a dependency on Lodash. Lodash is a really popular set of utilities for JavaScript, and it manifests itself as an underscore. So what we can do is we can use underscore.bind the function to this. Now this is a super compatible way of doing the same thing. Now it's not native in JavaScript. You have to bring in this utility library to do it. But it does give you the benefit of now I can do it in this style of gluing the context together, and it should work in every browser. Now, it's probably a little overkill for this particular example because I got one line here, but if you had a more complex callback with a lot of stuff going on, there might be design advantages to actually gluing context together.
Does that thing have a name? What's it called in the JavaScript feature?
I think it's just called function.bind. It was an extension as part of ES6. All right, so now we can delete statements right up until we get to ads. Sweet. All right, so here was our outlaw. Clara this and that context. Now this error this isn't something that would arise only in production. Like, this is a logical error. This is just a straight up bug in JavaScript. But it happens so much. JavaScript of apps of reasonable size gets so complex to test every possible edge condition of the order at which things happen in the network stack, in interaction stack, in timeout stacks, that even though it's theoretically possible to discover all of these through a robust set of unit testing, almost nobody does, because it's too expensive to test every single possible permutation. And so we still see this error as one of the most common things that happen in production. So this you can find anytime there's a functional argument. If you are passing a function as an argument into something else, and that function has the keyword this anywhere in it, throw up a red flag. Make sure you understand the context that that function is going to call back with. And that is like the key on how to do this. So this happens with callbacks, with promises, with async. Any of the ways you can do this, you're going to still have this problem, and you need to like make sure you understand the context if you're going to use the keyword this. Okay, let's move on to the next one. So this error is dolly data. Dolly data manifests as substring is not a function. And this one's pretty isolated. Like, we're not seeing very many people have this. In fact, only one person has this. We saw this error 2,000 times. But we saw it 2,000 times from one person. One person just reported this error that many times. And so, like, maybe you don't need to care, but like something is definitely going wrong for this person. And I want to see if we can fix it. So this particular person is seeing this a.text.substring is not a function. So let's take a look at Soliloquy and see if we can understand why that happens. So if I just refresh on my demo customer here, everything seems to work. So maybe it's something with this particular customer, right? So looking at my log, I see that, hey, this is customer ABC who's having this problem. So let's go and load their data. So when I load Soliloquy for this customer, they have a kind of a terrible experience here. They see nothing. Like, none of their stuff is there. None of their posts, none of their data. If they try to interact with it, it just goes away when you refresh. Nothing gets persisted. And they're seeing this error, a.text.substring is not a function. So something is definitely going wrong here. So let's take a look at statement model.js line 21, where this problem seems to be happening. So here's the error in question, or the line in question. And so it's happening right here. So let's break this down and see if we can figure out what's going on. So I have a function called parse. And parse takes this thing called resp, or response probably. So we're probably dealing with like getting some data from somewhere. And now we have some expectations on that data. It looks like we're transforming some data. We're using another low-__ function called map, which allows us to iterate over an array of objects and transform them from one thing into another. So we're looping over resp. So at this point, we already have an expectation. Resp is an array of objects, right? So we're looping over it. And then for every thing inside of it, we're setting a property called text on it. And we expect text to already exist. And we expect it to have a function on it called substring. So we have this set of expectations already of this data, where item is an object, it has a property called text, and text is a string, so that we have a substring function. But that's blowing up. So if we just set a breakpoint here and take a look at what actually happens when this runs, let's just give it a little refresh. We pop in, and let's take a look at what's in resp. I'm just going to go down here to the local scope and take a look. So here's our object. This is minified code, and so it's actually called A, even though the source map is showing me item. We don't need to talk about that right now. This is resp. So resp is an array. It's an array of objects. We already see that there are 101 objects in this array. So far, so good. We're matching our expectations. Let's take a look at one of these objects. if we pop into the object, we do see a property called text. But text is not a string. Text is a number. And a number does not have substring. I can't go into my console and type, I don't even remember what did it do? Substring 0140. Substring is not a function. That doesn't exist on number. So why is that happening? So if we look at our network itself, let's uncheck this breakpoint. Go. If we take a look at this network itself, the response that we're getting from our server indeed has an array of objects with a text property that's 42. So my app is blowing up because my client side has one set of expectations. My client side was written to expect I get an array of objects with a string on it. But my server returned an array of objects with a number on it. And my app blew up because it didn't know how to handle it. So if we take a look at the code in question, which was statement model, the server shouldn't have done that, right? Somebody probably made a mistake. Something got released, the API changed, somebody fat-fingered something. Maybe somebody attacked my API and inserted a piece of data that shouldn't have gotten in there. For whatever the reason, it happened. And so we should change our JavaScript to be more flexible. Like if this is an expectation that isn't always true, we should really be safe about it. So maybe what we should do is we should say, what if RESP doesn't even exist? Maybe we should say, hey, we're either going to iterate over RESP or we'll iterate over an empty array. Let's make sure that it's real. And now let's loop over the things in it. So we'll take a look at item. Well, item.text might not even exist. And if it does exist, it might not be a string, in which the case we have here. So we should just check that. We should say, like, if item is a thing, and if dot is string item dot text. So let's just be safe about it. We have these expectations. Let's call it out. So we're only going to do this transformation on item.text if it's not. But what happens if it's not? What should we do? If item.text is in the wrong format, we should probably do something. We should probably write something to our logs so that we know stuff's going wrong. So maybe we'll do a console.warn. We got bad data. We got bad data item. And then what do we do as far as the user? Because like item.text is probably a thing that the UI needs. So we should probably write item.text is invalid data or whatever. So if we put this in place and take a look at our code now, our UI actually loads now, because now we're able to process that data. So it's still not the greatest user experience in the world here, right? Because the user has a timeline full of invalid data messages. But we're at least able to show them something. The app just doesn't break on them overtly. And our logs themselves report something that is way more, that is much easier to understand what is actually going wrong. We don't see this something blew up because substring is not a function that will require diagnosis. We see that, hey, we got some bad data. Here was something we didn't expect that came down from the server. So this is the kind of error that happens when a client-side expectation doesn't match a server-side expectation, which as people are building more and more complex apps is happening a lot more. How many of your organizations have a different group of people working on the back-end APIs versus the client-side front-end application? You have a back-end team and a front-end team, right? This happens when you have two different teams. Somebody thinks the data type is X, it ends up being Y, the expectations don't match. Maybe the API releases code before the front end got out, and you have a mismatch. So this tends to happen, and you end up with a production fault. Two different teams working on different expectations. Happens anytime you see separate teams working on the two sides. The trouble with this is it's really difficult to prevent with standard style unit testing. Even if both the back-end team was testing all of their APIs and the front-end team was testing all of their expectations, the problem is that nobody ever integrated them together and actually ran through a test. And so you got to make sure that you're constantly monitoring on what actually happens, doing a full end-to-end test before you put stuff into production, and even watching when it's in production to make sure stuff doesn't change. This one is my favorite for Australia. This is script load failed. This manifests itself as something is not a function. Now this isn't happening a lot. We get about 2,400 hits a week on Soliloquy. And this has only happened 134 times. But it happened to 129 people. So this isn't like a one-off. This isn't one user with a bad situation. This isn't like an uncompatible browser. This is something that a significant amount of my customers are running into. And it's pervasive. There's more than it's happening to multiple people. So let's take a look and see if we can figure out why does a.inline ads, why does that break? I'm going to switch back to my standard customer, and we'll reload. All right, so looking at Soliloquy, refreshing it here, I do not see that error. It's not happening for me. Close the bug, works on my machine, right? Move on. Now, let's figure out why would this happen? So let's look in our code, and let's just do a search for inline ads. Where is that? Where does that come from? And that's defined in two places here. It's defined once in one of my advertising providers. One of my advertising providers defines this interface. When I use this provider, it says, hey, put our script on the page. We'll create this function called inline ads, and you set up your advertisement with that. So here's where window.inline ads comes from. And then I use window.inline ads here in my main Soliloquy.js file. So I'm setting up the page. I want to put some ads on the page, initialize it, and do some stuff. And so I don't know why this wouldn't be a function. I have one file that puts it on the page, and I have another file that uses it, and there's no real variability about either of those. So if we go and look at the actual HTML file that this comes from, I see, all right, here's inline ad provider. It's coming in right here. Here's where it would get defined. Why would it ever not get defined? Well, let's just pretend it's not there and see if we can recreate the problem. So if I just comment out inline ad provider is not on the page and reload, I absolutely get the error that was reported. This a.inline ads is not a function. So this is what's happening. But look at the user experience again. When this happens for those 130 some people, this is what Soliloquy looks like to them. It looks like crap. There's nothing here. None of my ads are there. I'm not making any money. Their timeline isn't there. If they were to type some stuff in and try and interact with it, it just doesn't do anything. It's just broken. And they're like, this Soliloquy thing sucks. I'm going to go back to Twitter. So that's not what I want. I want people to use this. So why would this happen? Why would this happen? And why this happens is probably way more clear to you than most people who I've talked to. Because you live in Australia. And sometimes stuff just doesn't load. And it happens a lot. At the recent Google I/O conference, they released some internal numbers from Android. And when Android is making an HTTP request, based on the network that it's on, between 1% and 4% of the time, that request just fails. Maybe the SSL handshake failed, maybe the DNS lookup failed, maybe you just went into an elevator and you lost connectivity, maybe you lived in Australia. A lot of times it's just the request doesn't work. And so that's what's happening here, is that on a significant percentage of time, inline ad provider JS doesn't come down. Now that could be any number of things. Maybe their DNS service is like slightly slower. Maybe it's just random and like various different scripts are like failing to load often. But when this particular script fails to load, it manifests itself in a really dangerous user experience and a really bad a bad experience for my customer. And so let's see if we can like be a little bit smarter about that. So here where I'm using that file is right here on line 38. I'm just calling a function called window.inlineAds and I'm setting it up. So I'm giving it my customer key. I'm saying, hey, I want to like show ads every 700 something, I don't remember. But we're just calling this function with our configuration. But what's happening in these small set of cases is sometimes inline ads isn't a function. It's not there. So let's check it. Let's just be obvious about it. Let's say, hey, if window.inlineAds is a thing, then let's set it up. And if it's not a thing, again, let's just put something into the log and say, inline ads failed again. Get them to give you some free stuff. And then just continue. Like inline ads, in the case of Soliloquy, it isn't a killer feature. If I don't have inline ads, are you really going to care? If you open Twitter tomorrow and all of a sudden all the inline ads were gone, do you care that much? Would it like negatively affect your experience? And so like this is something that's not critical for me. And so just by taking it out of the critical path and saying, hey, load inline ads if they're there, and if not, like, just move on, these customers, these 130 people a week who have this problem, they get a way better user experience. They don't even know that anything went wrong. And that's awesome. Like, it's still failing, but they don't need to have a bad experience. And so when we think about all of the different scripts that we're loading, all of the different things you assemble on your page, what happens if one of them isn't there? What happens if some random script as part of your overall app just doesn't come down? What's the experience? Is it a catastrophic? Things are just gone? And does it have to be? What if, hypothetical situation, you had a credit card checkout form and you used a third-party script to process that credit card, like Stripe or Braintree or PayPal or any of those? What would happen on that credit card form if their JS file didn't come down? Would it work? Would you have a customer typing in a credit card number and nothing happening and being really frustrated? Would your form take a credit card number and then go and post it somewhere because it didn't have the script to like intercept it and do the proper thing? There's all kinds of terrible things that can happen when just part of your application fails. And so we got to think in a safety mindset. The web is flaky. Parts of my script or parts of my app are going to fail, and we need to like fail gracefully when it does. All right, I only have time for one more error. This one's kind of fun. This is my browser crashing. And my browser crashing is manifest by slow performance and occasionally a browser crash. Now, the problem with a browser crash event is that all of the tools we have to monitor web applications are built in JavaScript. They're inside the application. And so when the browser itself goes down, like the whole runtime goes down with it. And so we don't know that it happened. Like the whole browser just disappeared and we can't get one more error report out the door on the way out. And so the only way we really know this is happening is when our customers complain. And unfortunately, they complain on Twitter and they say, Soliloquy's such a piece of junk. I'm like been typing all of my thoughts in it all day and like it just gets slower and slower and then it crashes and it sucks and I hate it so much. And that's bad publicity, one, and two, it's just really it's not a fun experience for them. So let's take a look at Soliloquy and see if we can understand what happened. So what we're hearing is that people use Soliloquy for a long duration and the performance suffers and then it crashes. And so that sounds like a memory leak. So there's a bunch of different tools that we can use to diagnose memory leaks. Who's diagnosed memory leaks before? Anybody? Sometimes it's terrible. But with some of the new tools here, I actually think it's kind of fun. So how I like to do it is I like to use the timeline function. inside of Chrome here. And what the timeline lets us do is it lets us record a series of events and it give us a playback of what's the browser actually doing when we were doing those things. Like what sort of events were happening in the JavaScript layer, what sort of events were being painted on the screen, and so we can like diagnose behavior. And so what I like to do here is I'm going to like type a few statements into Soliloquy, and then I'm going to delete those statements back out, which should hypothetically change the state of my application and then return it back to the original. And so I should expect everything to kind of level out. So I'm going to just refresh the page here quick, make sure everything's clean. And we'll start recording. And while that's recording, we'll say, hello, Sydney. You don't know what winter is. This is a mild spring day. And then I'm going to delete those. All right, so we've recorded about 24 seconds of activity. We'll take a look at what that looks like. And I know this is a little intimidating at the beginning. Like this screen just shoves so much data in your face. And so we're going to break it down and actually take a look. Now, the thing I think is confusing about this is that the place to start on this page isn't at the top. It's this line chart right here on the bottom half of my screen. This is the place to kind of see what's happening. And let me clean, I don't care about that. I don't care about that. What I care about here in terms of a memory leak is I want to know what is the JavaScript using in terms of its memory, how many HTML nodes are on the page, because the size of the page is a reflection of like how much memory the browser is using, and I want to know how many listeners are attached to those nodes, because that is a direct correlation back to how much JavaScript needs to remain in browser memory to deal with callbacks to those sort of events. The more listeners you have, the more JavaScript can't be garbage collected. And so when we look at this, here, like there's a bunch of stuff happening. Like there's definitely a few drops. There's a few garbage cleanup events that happen. But for the most part, we are kind of stepping up as we go. And like we're ending with significantly more nodes and listeners than we had when we started. So like there definitely is something there's definitely something going on. We're not right back where we started. So let's start digging in further. And so what's cool about this is that this is your 10,000 foot view. This is like in general what happened. But now we can like start zooming in and see like the nitty-gritty details. So I used to play a whole lot of video games. An unhealthy amount of video games. And one of my favorite, I used to play a lot of first-person shooters on computers. And so the controls for all those games is WASD on your keyboard, right? So you could have like one hand over here and the other on your mouse and really rock some headshots. It's the same controls. It's like it's a video game. So we can interact. Come on. It's all right. Please wait. There we go. So we can interact with our charts if you get the right focus window, which is this little thing right here in the middle. If you get your focus window right there, you can interact with this just like a video game, where you're like zooming in, zooming out, strafing left, strafing right, dodging bullets, taking a look at JavaScript errors. So what I want to zoom in on here is this step function. Here I see a series of things that every time this is happening, it's ticking up my usage of both nodes, memory, and listeners. And I want to see what's going on. So let's just keep zooming in. And the closer we get on one of these, we see that like, come on, it's not one big step happening. There's a bunch of little actions all happening together. And we see it happening not just once, but like multiple times over the course of this of the lifetime of this app. So I'm going to zoom in here on this one, and we're going to take a look at what exactly is going on. So the closer we get here, our view, I'm going to drag this down here a little bit. Our view here begins looking not just like lines, but we can actually see what was going on that was causing these things. So I can actually see real JavaScript that was executing. Now we're like really fine grained. We're talking about a difference of, 18,650 milliseconds to 18,651 milliseconds. We are going real nitpicky here. But here's what was actually happening at this timing, is I see a timer fired. That timer fired this thing in sidebar ad provider, which called a function called place ad, which triggered some AJAX. While this was happening, the number of nodes went up. If we keep going, we see a timer fired again, the same pattern, nodes went up. Same, timer fired, sidebar ad provider, place ad, nodes went up. If we scroll over a little bit more, we see it again. And then here's something just a little bit different. We see an XHR ready state change. So that's an AJAX completed. An AJAX finished. We called a callback. We did some stuff. Don't have quite enough screen real estate to show you much more. It called a function called place add success, and the number of nodes and memory went up. And so we have this pattern that in rapid succession, the number of nodes are going up, and it has to do with this sidebar ad provider. So let's take a look at sidebar ad provider and see if we can reason about what happened. Here's a function that we saw in our timeline, place add. And place add is happening inside of a set interval. So that's a timer firing. Every so many milliseconds, we're on a loop where this callback just says, every so many milliseconds, call me. So that's where we see a timer going off. It's calling place add. Well, what does place add do? Place add is going out and making an AJAX call. One of the other things we saw that was contributing is an XHR finishing, and we saw whatever was happening in response to that AJAX finishing was increasing the amount of memory pressure. We saw place add success. So this seems to be related to the memory leak. So what's actually happening here is in set interval, the first thing we do is we clear out some HTML container. We have some element, it's got some HTML in it, we zero it out. Then we go and make an AJAX call to a server, and we get some new content. We get a new advertisement. And we take that advertisement and we shove it into the container again. And then we attach a click handler so that we know when the user clicked on the ad. So you can see it kind of happening here. On that right-hand sidebar, we see every few milliseconds, the container for all of those ads zeroes itself out. We make a bunch of calls and get new ads. We put them in there, and we wire up click handlers. The problem here is that we've wired up this click handler, but we've never unwired the click handler. So even though we took all of those elements and we threw them away when we zeroed out the container, there's still this little bit of JavaScript attached to those elements, waiting to be clicked on. They're hanging out, even though they're not visible, they're not recoverable, but this function is attached to it, and so neither can be garbage collected. And they just sit there and grow. So when we see this happening, all of these ads that are on the page right now for bears, they're still there. They're just floating out in the netherworld, waiting for something that can never happen. And so our customers who use Soliloquy all day, after several hours, there could be literally millions of pictures of Crocodile Dundee just waiting to be clicked on. And it takes down Chrome. The wanting to be clicked on takes down the browser. And so that is my browser crashing. That is the core thing that causes memory leaks is detached DOM elements. It's why it's a core thing in looking at memory tools. It's when you have an element and you remove it from the core DOM, but something is referencing it. There's an event listener still attached to it that causes so much of the browser's memory to be retained waiting for these events to happen. And the characteristics of this is slow performance and eventually crashing. If your app does any sort of client-side rendering, this is a possibility. Unfortunately, there's not a really good way to monitor for these sort of things. And so I'd encourage you, if you're building one of these ambitious client-side apps, you need to periodically scan for it. And the tools are pretty cool, and you can kind of learn a lot about the base level of browser interaction simply by looking at the core things of what is the browser doing when you're doing these sort of interactions. So these were the outlaw. Yeah, go for it. Yeah, exactly. So the question was, could we have avoided the memory leak by calling off? Exactly. You avoid it by calling off. When rather than just of clearing all the elements out, we should have gone through them and detached all the click handlers, then cleared out the element. That would have allowed the whole thing to be garbage collected. You're right. I probably should have actually like fixed it, but I'm kind of running short on time. We could hack on it after if you want. All right. So these were the errors that we captured today. These were the outlaws. First, Scripty Joe. It's browser obfuscation. It's the first error that you're going to have to deal with to actually get a better picture of what's going on in your client-side environment. The second is Jane Adsy. Anytime you're introducing a third-party script, you're introducing some risk in your application that some other organization can make changes to your production app. Clara context is one of the most common JavaScript development errors. It's a misunderstanding of context. And the complexity of JavaScript apps tend that these even make it into production. Dolly data, a misunderstanding of a contract expectation between a client side and the server side. If you have multiple different things happening, multiple different teams working, eventually somebody's going to miss, and you need to have ways to like test for this during your deployment or monitor for this in production. Logan, no loadin'. This one's obvious for y'all. Sometimes the internet breaks. You need to code your client-side app defensively so that when an arbitrary script in your application fails to load, what is the experience you give to your user? Can you gracefully fall back? And finally, my browser crashing. Memory leaks happen when you do client-side rendering. You need to periodically check your apps to make sure you're not using up all the memory of your customers and causing all of their MacBook fans to spin up like jet airplanes. We did all of that with the help of Track.js. So Track.js is a company that I started, does JavaScript error monitoring. All of the data that we have today was based off of some analytical tools we took over the errors that have been captured over the last 6 to 12 months. So this is like really the most common errors that happen in the real world. And I am Todd Gardner.